Okay, so now it's time for the third equation or third question for the exam, which is the paintball question. And here is my work for this one. Here are my kinematic equations. And then, so we're given the delta y and the delta x, which are just like the length from the tree, which is 17 meters, and then the height of the knot hole, which is 8 meters. And then the velocity that the paintball is shot from the paintball gun. And then I calculated the length of the hypotenuse, but we didn't really need that. But we do need the angle, and so I calculated that using the trig rule using tangent. And so it's the tangent of theta equals opposite over adjacent, and then that's 8 over 17, and then theta equals inverse tan of 8 over 17, and so I kind of drew a line through it, but theta equals 25.2 degrees. And then using that, we can get our components from the gun. And so the x components, or the x component of the paintball being shot is 50 cosine of theta, because it's shot at 50 meters per second. So it's 50 cosine of 25.2, and that gives us the x component is 45.24. And then the y component is 50 sine theta, which is 50 sine 25.2, which gives us 21.29 as our y component of the paintball. And then, so we want to figure out time that it takes to go the x distance to figure out how high up it goes in the y, because we're trying to figure out where it hits the tree since it misses the knot hole. And so using time, we use this kinematic equation, the delta x equals vi times t plus 1/2 at squared. And so since it's in the x direction, our acceleration is 0, so that whole value is just 0. And so we just plug in the numbers we have, and so it's our delta x, which is 17, our x component of velocity, which is 45.24, and then we can divide this across to get our time, which is 0.376 seconds. And then we can get our actual delta y by plugging that time in to this equation, that same kinematic equation, but solving for delta y in the y direction. And so delta y equals vyi times time, and then plus 1/2 at squared. And neither of these values are going to be 0, so you plug in all your numbers here, and so you get your y component of the paintball, which is 21.29, and then times by time, which is 0.376, and then added to 1/2 times negative 9.8 and times 0.376 squared. And so when you multiply these numbers together, you get 8.005 plus a negative 0.6796927, and then when you combine these two numbers, you get delta y equals 7.312 meters. And then I just subtracted this number from the ideal delta y, and so we get that the paintball hit 0.688 meters below the knot hole. And that's how I did this one.